All right, so let's take a look at the next one, which is 124. So 124 is DLL hijacking, and this one is very interesting. So here we talk about disabling Windows Defender, which you can do in local group policy or by adding an exception at the root of C or various other ways. And Metasploit is already installed on these machines. So we're going to make malware with this command. And so again, I'm going to shove this to the side and do it live. So let's go to an administrator command prompt. Run as administrator. Okay. And now go into my downloads folder, which is users, IE user, downloads. And I guess I'll make this big. Now, I want to put in this long command, which I'm going to copy and paste. Oh, first let's see what's in here. Let's see if I already have something called shellbind in here. And I do not. Good. Okay, good. So clear. Oh, that's right. I don't CLS in Windows. All right. So here's the long command. Let's see if it'll copy and paste. It did. All right. So this is Metasploit Framework MSF Venom. MSF Venom is the Metasploit tool to create malware. And now this is going to create malware called shellbind.dll. I missed the last few letters. And that'll be a library piece of malware. And that malware will be a 64-bit shellbind, which will start listening on port 4444 and let you control the machine. So it's working. And again, you have to have a machine with no anti-malware running, because Metasploit will totally freak out any machine. So here it is, complaining about the fact that Metasploit uses some old libraries, which is fine. I don't care. There it runs. It created a DLL 8704 bytes. So it's done. It's now created malware. Now we have to turn off the firewall because this is shellcode, which I was talking about earlier. Shellcode is very small, very efficient code, but it doesn't have any error handling. If anything goes wrong launching a shell, it will just crash. And this one's going to try to open a listening socket. And if the firewall stops it, it will just crash. So you have to turn off the firewall or the shellcode will not run. So go to your Windows Defender firewall and turn it off. And it is in fact off for the network I'm on. This is not the kind of network I'm using, but I'm just going to turn it off for every environment just to make my life simpler. Okay, now it's off, off, off. Good. Now we're going to mess with services. We're going to use a Windows service, which is here. Okay. We're going to look at the MSDTC service, which is the Distributed Transaction Coordinator. And what this is, it is here. This is a service that coordinates transactions that span multiple resource managers like databases, message queues, and file systems. Whatever it is, it doesn't really matter. Windows 10 has a lot of these things running that you don't really need, which is handy for us. We can mess with them without breaking anything important. So, now from the status, we can see this one has startup manual, but I think it was originally automatic. Maybe I've modified it. Mine was originally, oh, it's a manual. Anyway, all right. So anyway, from status, it's running. All right. So we are going to examine its properties. Services launch before you log in, so they can't launch with your account. They launch with the other accounts, like network service or system. And we want to set this one to launch as system, which is the default for many processes, but for some reason not for this one. And that's just so it's more obvious when we take over the machine. The other setting would probably be fine, but this is the one. I followed somebody's blog to write this project, and we'll just stick to those steps because it makes the project run all right. And I'm not concerned with the details at that level. So we'll stop the process, and now we're going to watch it in Process Monitor. So procmon, we're going to watch how it loads libraries. This is the main thing I do with Process Monitor, because libraries are a common source of vulnerabilities. So I want to I don't want this one. I'm going to remove that one. I do like this. I want things with path that ends with DIL, but I also want to add process name contains MSDTC. That's the name of this thing. So now I say OK and add. So now I'm going to only see things that match those events. And so it shows me its number counting up down here. The current filter excludes all 9,000, 10,000 events. It's showing all these events are going by, but I'm not seeing any of them. So now I can launch that process. So I start it in services. Right here, I start it. And now I look here and I see a lot of information. And I'm going to stop sniffing now with the third button because I have the information I need. And what I want to do is find the OCI.dil entry. So I just look down here and I'll find that that was name not found. So let me adjust my columns a little bit here. There we are. All right, I want to see the result here is going to be name not found. And I could even sort by that column, but it's not a very long list, so I'm just going to hunt for the word name not found here. There's name not, here it is, OCI.dil, name not found. So what happened is, it's trying to load all these libraries, like MSX OCI and MSDTCPRX.dil. And here, it tries to load something called OCI.dil, and name is not found. And it doesn't try anymore. It's just done. It looks for it, it's not there, and it just keeps going. So that's interesting. Let's look at it in Process Explorer. Why didn't the program crash if it looked for a library it needed and didn't find it? Well, here's Process Explorer. And if we look up here in kernel land, we can see the background processes. And somewhere up here will be MSDTC. Probably down towards the bottom. Yep, there it is, MSDTC. So it's running, and if I turn on the lower pane view, show lower pane, and then I do view lower pane view DILs, it will show me the libraries, but unfortunately I can't see them now because I launched Process Monitor without system privileges, without administrator privileges. And I can't see kernel process details this way, so I need to relaunch Process Explorer. Process Explorer, I need to run as administrator. Okay, and now, yes, we're in the fullness of time, there we go. Now I need to find MSDTC, which was down towards the bottom of kernel land. There it is. And now, here I see the DILs. And you see they're in alphabetical order. Here's the K, L, M, N, O, and the one called OCI is not there. So, this is an interesting situation. It asks for the OCI library, it looks for it, it doesn't find it, it launches, and it's running just fine without it. So what's going on here is a developer had an include statement in the code asking for that library, but then they never actually used it. This is a fairly common mistake for a developer to make, especially with big complicated programs with a lot of versions. Whatever that OCI.dil thing is, it's apparently no longer included in Windows 10, but the program still asks for it, but it doesn't actually use it. So that creates a kind of vulnerability. The program is looking for OCI.dil, and it would load it if it was there. So if I put malware in and I name it OCI.dil, this program will load it. And that's what we're going to do. So all we have to do is position the malicious DIL. So here we do net stop the program MSDTC. This is the same thing as stopping it in the services panel. I should stop it from running. Now I'm just going to copy the shell bind to C Windows System 32 on top of OCI.dil. So this will take the malicious DIL and put it in the location C Windows System 32 OCI.dil. Now, Microsoft ought to be verifying signatures before loading libraries, but they don't. So it'll just take a piece of malware written by Metasploit and load it as if it was a Microsoft Windows library, which is outrageous. So now I can do net start msdtc, and it starts. And when it starts, it gets to where it loads the malware. Yes, it does need administrative privileges to copy to that directory. So in fact, I'm not really accomplishing anything with this attack. It's just demonstrating the... Now, it doesn't really finish starting because that malware is kind of fouled up. But the point is, I now own the box. If I go here and open another command prompt here, open, now I can do netstat -an pipe more. And I'll see it is now listening on port 4444. And that means it's now connecting. And so if I do ncat 127.0.0.1 on 4444, I'm now in the machine. And if I do who am I? I'm now system. So I've elevated from administrator to system. Does Windows have something like LD library and path to tell it where to look for libraries? No. It does have a path, yes. But each program makes its own decision. And as you'll see, especially if you go to the next project, some programs wander through the path, which means they start by looking in the current directory, like the downloads folder, and then like the user's home folder, and then the My System folder. This has been a problem of Windows right from the very start. Even Windows NT 3.5 had this problem. When it loaded Explorer to draw the desktop, it did not specify the path. Instead, it hunted everywhere. So this was a way you would hack into Windows boxes right from the start, was by just putting a fake explorer.exe in a different directory, and it would launch it. You could get in boxes. It was a way to bypass login and all sorts of things. So anyway, this is called a companion Trojan attack. Now, this particular one doesn't really accomplish anything. We already had administrator rights, and now we're just elevated to system rights, and there's a lot of ways to do that. So this attack demonstrates the technique, but this particular one doesn't accomplish anything. Now, if you want to accomplish something, that's the next one, which I think I'll demonstrate next time because I want to demonstrate some OLLI tonight, but I'll point you to it today. If you go to 126, this is where you actually do DLL proxying, where you actually manage to make a fake library in a user land that doesn't require administrator privileges, lets you escalate. So it can be done, but it's more complicated. You have to make a smarter piece of malware than what we just made. The malware created by Metasploit is really pretty dumb. It doesn't have any legitimate functions, so it will not fool a program that actually uses the library. It'll only fool a program that is so stupid as to load a library and then not use it. Now that happens, but the DLL proxying can fool a program that loads a library and uses it. You can build a library that reproduces all the functions of the system library in addition to adding malware to it. And that's cooler. And that's what you do in 126. Anyway, that's the second thing I wanted to show you.